Okay, so this is number 41 in 8.1. And I'm going to have to make some assumptions here, I think. So I have two towers. There's a tower called the Columbia Tower.
And there's 954 feet tall.
That would be in Seattle, Gabe. I don't believe there's a 954-foot tall building in Tuolumne County. There
The
are.
tallest building is the parking garage at Black Oak Casino.
Yeah. What's that amount to? 80 feet, maybe?
Probably higher than that.
Yeah. So there's a couple of big things in Tuolumne County, but they're like dams and cliffs and giant ass trees. Not so much with the big skyscrapers, but I'd rather have the trees anyway. So we got our 954-foot Columbia building, and then over here there's some other building. I forgot the name of it, and I don't care, so don't read it. And there, let's see, we found that there's a 37-degree angle if you stand at the base of the Columbia Tower and look up at the top of this other one, and a 53-degree angle if you stand at the base of the other tower and look back up at the top of the Columbia Tower. And they want me to find the distance between the two and the height of the short one. So how am I going to do that? Well. Okay, that's a good idea, because I always end up with tangled diagrams, right? So let me pull those two triangles out. So there's this one, and then there's this one. This one's got a 37-degree angle in it, and the big one's got a 53-degree angle in it, and I know this side is 954. And then what else do I know here? Yeah, the bottoms on both of them are X, and the height on the 37-degree triangle is Y.
Is that Y perpendicular?
Oh, that's a really good question. I think without that, I probably don't stand a chance of doing this problem.
Yeah.
So why would I think that these are probably perpendicular? Yeah, I'm gonna go ahead and assume that this almost 1,000-foot tall skyscraper was built reasonably and it sticks straight out of the ground.
Yeah.
Is that a bad assumption?
I would not go in that building if it wasn't up, straight up and down.
Yeah, it was a degree off. That's a big overhang on one
I
side.
mean, those buildings usually built to sway a little bit.
Yep, they sway and twist in the wind. They're super cool.
But initially built, it should be built straight up.
Yeah, I'm going to assume that it's roughly perpendicular most of the time, and that the sway is around perpendicular. What's up, Bob?
I can't help but notice those are the same triangles, just scaled differently. Because the other angle in that first one would be 37 degrees.
The other angle in the first one. Oh, up here?
Yeah,
This guy.
Oh, yeah.
Yeah.
same triangle.
You guys see that?
Pretty good.
Yeah.
Okay. Do I need to know that?
Not really, but it's kind of.
It's, I mean, you can just label the other one if you really wanted to.
Okay.
You don't have to.
So, how did you get that? 37
Plus 53 is 90.
plus 53 is 90? Cool. So this other angle is 53 degrees too? Neat. So I've done a shitty job of drawing these triangles. That's clear.
Wait a second.
So what do I actually need to find x?
Some sine and cosine stuff.
Some sine and cosine stuff, right?
Oh.
So what do I know about that triangle right there?
You know that the
Wait,
Wait, are we trying to find Y or no? Or
I'm trying to find both y and x.
You know that the tangent of 53 degrees is 954 over x.
Okay. You guys see that?
Yeah.
Okay, so tangent of 53 degrees is the opposite, 954, over x. So x then is what?
954 divided by tangent of 53 degrees.
Perfect. 954 over tangent of 53 degrees.
8.
Okay? What do you know about y?
You know that 37, or the tangent of 37 is y over the base for the last one.
Good. tangent of 37 degrees is y over the answer to the other problem, right? X. Okay? So y then is x tangent 37 degrees. And I know what x is. It's that crap. So we can just plug that right in. So I'll get x is 954 over tangent of 53 degrees. Can somebody get me a decimal approximation for this? And y is 954 tangent of 37 degrees divided by the tangent of 53 degrees.
Make sure you're in degrees.
Yeah, and make sure you're in degrees.
718.9.
So that's x
Yeah.
is approximately 718.9. And what are the units on that?
Oh,
what
did
they
give you,
Oh, feet, because it's different.
Feet, because the 954's units are
feet?
feet and tangent's just a ratio, right? So it's unitless.
Oh, wow, that's
And y is
good. 541.7.
541.7. And the units on that one are feet also. Cool. Questions, yes? What?
I use the law of cosines for the big triangle, and
How did you use the law of cosines for the big triangle?
or sorry, law of sine.
You've used the law of sines for the big triangle.
Yes.
Okay.
And I got 725. Did I screw up or
Yes.
okay, cool.
Let's see how. So let's try that. Okay, so you took the, hang on, sorry, before I answer that, these two, do these seem reasonable?
Yeah.
Okay, what is a corollary that's interesting to this? If
Yeah,
the
the
Columbia Tower fell down like a tree, right?
Yeah.
You get hit the other one with it. Peek. Just, you might note if you happen to be in Seattle with a really giant chainsaw. Don't cut down the Columbia building, you'll hit the other one.
But if you cut down the other building, you won't hit it.
And if you cut down the other one, you won't hit the Columbia building. Useful to know. Cool? Okay. Now, law of sines. Which two things what did you try? You did
53 and 954. Sine of 53
Okay, so you did sine of 53
over 9,
over 954
and then sine of 37 over that.
is sine of 37 degrees over x. Okay, so then you solved, and I hope you got x is 954 sine of 37 degrees over sine of 53 degrees. And when you plug this in, you got something not 718.
725. Slightly off.
Okay, so where'd this slightly off come from?
I have no idea.
So did you plugged 37 into a calculator, wrote it down,
No.
plugged 35, no.
That's,
What did you do? Did you type in the whole thing?
no. I'm just using.
You're using a little calculator, right?
Mhm.
So you did like this step,
Yeah.
the top, and then you wrote the answer down, and then you got the bottom, and then you wrote the answer down, and then you took the top divided by the bottom?
You still get 718.
Yeah, so if you type the whole thing in, you'll get 718. But if you do this bit, the top, and then round,
And butcher
and then round the bottom,
Uh,
if you're rounding pretty hard, right, when you take that division, you'll get a lot of error.
yeah.
Rounding.
Yeah, that's pure rounding error.
Yeah.
You still get 718.
And Gabe still insists.
What?
Yeah, so yes, if you punch the whole thing into a calculator, that's your best bet for getting a good answer. If you're writing down bits and bobs, you're likely to be rounding at each stage, and the more times you round, the worse it's going to get. Cool?
Cool.
And it helps if you round right.
I did round it right. It was 574.1.